Hi, welcome back. So now we are in this video we are going to move to the third problem. We are going to analyze the third problem, that is the last problem on this truss. That is, question is, you have to the truss as shown in figure, find the nodal displacement as well as stress in each element, and also we need to find the reactions at the supports. So now take E is equal to 200 GPa as well as area is 750 mm square. Now this is a figure now arrangement. There are totally 5 bars are there, and it consists of 4 nodes. At node 1 and node 4 it's completely fixed. Node 2 it is having a roller support, and node 2 it is subject to a load of 100 kiloton on x direction. Node 3 it is 200 kiloton on y direction. So let me analyze using Ansys. Now we can see when you're selecting number of type of link, so it is all real constant is same and it is made of the same material, therefore we can select only one link and you can create one real constant. In previous problem we have taken number of links based on the number of bars, but let me analyze this problem in a single using link one. So let's get into the answers now. So go to preprocessor, structural, okay, then preprocessor, element type, add. I'm going to select only one link, okay, and I'm going to give a real constant. So that real constant will be area. So that area is 750 mm square. So let me create this, and now so I'm created only one real constant and one. Okay, now let's move to the material models, and it is only one material models, therefore go to isotropic, and so here we are converting everything in mm. The E is 200 GPa, therefore we are going to get Newton per mm square as e power 3, and this is 0.3. Okay, now let me close this window, then go to material models right now. Now we need to create a nodes. So before creating a nodes, let me check out the coordinate system. At node 1 is 0 0 0, node 2 is 1500 comma 0 0, node 3 is 1500 comma and y direction is 750 comma 0. At node 4 is x is 0 comma y is 750 mm comma 0. So let's give the same thing now. 1 0 0 2, and x direction how much? It is 1500 on x direction, whereas node 3 x is 1500 whereas y is 750, correct? Then let me go to the fourth. X is 0 because it is on the origin side only, but whereas y is plus 750. Press OK. Now we got 4 links. Therefore by joining these links we are creating a elements through nodes 1 to 2, press apply, 2 to 3, press apply, 3 to 4, press apply, as well as 4 to 1, apply, and one more is 1 to 3, press OK. So now we complete the modeling part. Let me create a define loads, apply structural displacement on nodes. So let me select node 1 and node 4. We need to constant in r direction, whereas displacement on node 2 it is roller support, therefore it should be constant in y direction. Now we need to apply a force, that is on nodes. At node 2 we need to give a x direction. What is the value of that? Magnitude is 100 kilonewton. Let me give in Newton. 100 e power 3 plus, towards the right is plus, apply. Then we have to select at node 3 also load, but that is in y direction. What is the magnitude? So that is negative y direction, 200 kilonewton. So minus 200 e power 3, press OK. Then we completed the now pre-processing part. Let me go for solution, then solve this. So we can press OK. Solution is done without any error. Then we need to view the results. go for list results and check out the reaction data. Now you can check now node 1 and only where the reaction will be produced on node 1, node 2, node 4 because it is fixed. Node 3 there is no reactions. So this is the reaction solution now. Okay, so keep this in mind. Node 1 and node 4 it is fixed in all directions, therefore x also there is a reaction, y direction also there is a reaction, whereas the at node 2 only it is in y direction because x direction there is no constraint, so therefore we got fy. This one it is everything in Newton now. This is a solution, you have to get it. Let me check the element stress. For that we need to define table, add, and we can give by sequence number ls comma 1. Press ok, then close it. Now we need to see these results. They call list results, element table, select ls1, press ok. Now you can check this is a 5 element. Each element the stress is at element 1 133.3 Newton per meter square, and it is positive, that is tensile, whereas note at element 2 it is minus 253, that is compression. Note at element 3 it is 26. Element 4 there is no stress, keep this in mind, but element 5 it is minus 29.5, so that is under compression. So this is what we got the results, element stress. And also we need to check the nodal displacement. For that nodal solution, let me check in x direction. So at node 1 there is no movement, there is no displacement. So 2 3 only we have the displacement. Node 4 also it is fixed, therefore there is no displacement. So this is a nodal solution, that is in terms of mm in x direction. Similarly click on again nodal solution. What is the on y direction? Again node 1 node 4 0, whereas node 2 it is 0 now. Node 2 in y direction it is constant, that's all. Only node 3 it is minus 0.95 and negative direction. And finally we can see the graphical representation of the stresses. Contour plot, element table, then press ok. So this was a final stresses in a graphical representation. And also one more thing, suppose if you wanted to see like animations, so means when you are applying this load, how this is going to be movement take place. That means we can view the animation also here, so that we are going to check out now. Okay, to view the animation you have to go for plot controls, then animate. You can take the deform shape and press ok. Now you can see this is a deformation because of applying load on x and y direction. Node 1 and node 2 it is going to displacement like this. So by this we completed the third problem on trusses. That means we completed all the problems on the trusses. I hope you are all understood. Thank you.